In this video, we will write the electronic configuration of an atom. Electronic configuration is a numeric representation of its electron orbitals. Through this, we can quickly and simply identify how many electron orbitals an atom has, as well as the number of electrons populating each of its orbital. It is very important that you know, or at least you are familiar with the symbols of elements and where to locate atomic number. Remember, in our past video, we are able to use both the atomic number and atomic mass in our lesson entitled Subatomic Particles. You can click the link on top to revisit the lesson. Now going back, the atom has an sp-def orbital. Think of these orbitals as vehicles for electrons, while the electrons are the passengers. Now each of these orbitals has maximum occupancy for electrons. The s orbital has a maximum occupancy of 2 electrons. The p orbitals has a maximum occupancy of 6. The d orbitals has a maximum occupancy of 10, while the f orbital has a maximum occupancy of 14 electrons. Now let's see this situation. I'm going to draw it here so that we can be able to illustrate it clear for everyone. Now let's imagine that the s orbital is a car which can accommodate only 2 passengers, while p orbital is a vehicle which can accommodate maximum of 6 passengers. The d orbital can accommodate 10, 2, 4, 6, 8, 10. That's the maximum occupancy for d. And for the f orbital, the maximum occupancy is 14. 2, 4, 6, 8, 10, 12, 14. So say for examples, these are the electrons as the passengers. So let's say for example, we have a lot of electrons waiting in line just to be able to ride each of these passenger cars. Say for example, they are going home and they want to go home immediately. So we will try to see what electronic configuration is. Okay, so let's see if this would be enough. So this is the population of people or electrons waiting at the bus stop, and they want to ride each of the passenger cars. So meaning to say, for the s orbital, it can accommodate 1, or at maximum, it can accommodate 2. After which, it cannot accommodate any electrons anymore. So after which, we have the p orbital. The p orbital can accommodate 6 maximum electrons. Meaning to say, it can occupy 1, or 2, or 3, 4, 5, and at most will be 6. Now for the orbital, we have at least 10 capacity for passengers. The same way with the s and p, it can accommodate 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's the maximum occupancy for the d orbital. And for the f orbital, it can accommodate maximum of 14 passengers. Meaning it accommodates 1, 2, 3, 4, 5, 6, 7. There are still 7 remaining seats in the f orbital, meaning to say it can still accommodate 7. So if there's still another passenger here, another e passenger here, another one, they can all be accommodated here. So that's basically the maximum occupancy per orbitals in our topic about electronic configuration. So that's just an analogy. So let's come now to writing the electronic configuration. In order for you to write the electronic configuration of an atom, you need to use the this one. This is the sequence of the different orbitals found in the periodic table of elements. It starts with the s orbital, and then followed by the 2s, followed by the 2p. Just have to follow through the arrow. 2p, 3s, 3p, 4s, followed by 3d, 4p, 5s, followed by 4d, 5p, 6s, 4f, 5d, 6p, 7p, 5p, 6d, 7p, up to 8s. So that's basically the sequence of the orbitals in the of an atom. But then, if you need to memorize this, should you want to memorize, you may. But then we also have a mnemonic device that can be used in order for you to have an easy writing of the electronic configuration. This mnemonic device is used personally by me in order to write the correct electronic configuration of an atom. So it starts with 1 to 7, the first row, and all of them will be S, followed by 2 to 7, all P, followed by 3 to 6, all D, and then 4, 5, F. So I'm going back to our whiteboard in order to show you how to write the mnemonic device. Okay. So the mnemonic device in writing electronic configuration would be like this. You start first by writing 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. Then followed by numbers 2 to 8. 2, 3, 4, 5, 6, 7, 8. Followed by 3 to 7. 3, 4, 5, 6, 7. Followed by 4 to 4, 5, 6. Okay. So the first line would be all S. These are all S orbitals. The second line would be all P orbitals. Let's just remove here. I have there's too much in the second row. Okay, so P for the second line, and then D for the third line. The dog is barking outside. D for the third line, and F for the last line. And then you will be writing your arrow here, and then another arrow here, another one here, another one here, and then there goes the next one. Also have it here, and then here, and the last one. So the sequence will be starting from the end point of the arrow going to the arrowhead. So meaning to say, if you have here 1s, it will then be followed by 2s, followed by 2p, followed by 3s, and then followed by 4p, and then 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, and the last group is 5f, 6d, 7p, and 8s. So that's basically how you write the mnemonic device. So please do familiarize yourselves in writing your own mnemonic device, so that you need not to memorize the sequence of the orbitals that I presented a while ago. Now that you are set with your mnemonic device, it's time for you now to look at the periodic table of elements. Remember in our lesson, we have tried to look for the atomic number and atomic mass of an atom. Now this time we will go back to the periodic table, but we want to see there only the atomic number. So let's try sodium. The atomic number of sodium, okay, let me go back. The atomic number of sodium based from our periodic table of elements is 11. So what we only need here is the atomic number of 11. So going back here, I want to write first the symbol of the element hydrogen. Is it hydrogen? It's sodium. We want to write sodium. The symbol is Na, and the atomic number is 11. When we say 11, how many protons or electrons does it have? You are correct. There are also 11 electrons found in the element sodium. So meaning to say, we need to write now the placement of electrons in the atomic orbitals through the electronic configuration. So we shall start here with a 1s. So we write here 1s. Remember our maximum occupancy of orbitals, maximum occupancy of electrons per orbitals that we discussed a little later, the passenger car and the passenger. So how many electrons can populate the s orbital? Okay, there can only be 2, so the maximum. There are 11 passengers here, meaning to say 11 minus 2, because there are already 2 passengers in the s orbital. So this leaves us with only 9. And then it will be followed by this 2s. So you have to write here 2s. Since it's also in the s orbital, the maximum occupancy again is 2. So you will subtract 2 from the 9. You write the 2 here, so giving us only 7. So there are only remaining 7 electrons that needs to be properly located in each orbital. After 2s is 2p. So you write here 2p. The maximum occupancy of electrons for letter P is 6. So you get all the 6 here, minus 6. You put all the 6 here, you are left with 1. After 2p, we have 3s. So I'll try to write here 3s. The maximum occupancy for the s orbital is 2. There is only 1 here, so meaning to say, you just have to write the 1 here. And so that leaves us with our electronic configuration of 1s2, 1s2, 2s2, 2p6, 3s1. So that's basically how you write the electronic configuration of the element sodium. Let's try another one. So I'm erasing this first. I will not erase the mnemonic device so that we will be having a guide throughout the writing of the electronic configuration. So let's go back to the periodic table of elements. Now let's try to write the electronic configuration for chlorine. We have here chlorine, and the atomic number for chlorine is 17. So let's not forget number 17 and go back to this one. Okay, let's write first the symbol for chlorine, which is Cl, and the atomic number is 17. I almost forgot. Is it 17 or 15? Okay, it's 17. So the same process, we will go to our mnemonic device, and every time there is occupancy of electrons, that should be deducted from the total atomic number. Okay, so let's start. 1s 2. So that gives us only 15. And then followed by 2s2. So how many? Only 13. Followed by 2p. Let's get the maximum occupancy of 6. Now remember, all orbitals should be completely filled in before jumping into the next orbital. You cannot just leave, say for example, the 2s2 with 1. It should be completely filled before it goes to the next orbital. Okay, so please take note of that. So we now have 2p6 and then followed by 3s. Have we subtracted already the 6 here? Not yet, so we are left with 7. Okay, so the maximum occupancy for S is 2, so that gives us now 5. After the 3s, we now have the 3p. The maximum occupancy for p is 6, but we are left with 5, so just have to copy the 5 here and rewrite the electronic configuration. So the electronic configuration now for chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. Okay, one last example for this. Now let's try an easier one. Let's have boron 5. Boron is symbolized by letter B, and it only has 5 electrons. Now, using again the mnemonic device, we shall start with the 1s and then following through it. So, 1s2. So 5 minus 2, that leaves us with 3, followed by 2s2. We only have 1 left, so that gives us 2p1. So that's the electronic configuration for boron, 1s2, 2s2, 2p1. So that's how you write electronic configuration of an atom.